videos.
I did watch the video.
That's my virtual
Pay
kid.
attention to math, not secret code words.
Yeah, this is supposed to be.
Like
Good luck on your test on Friday.
I watched the videos. I don't know what you're talking about.
Good luck.
Okay, thank you.
It's like one of those tests that's like read the directions all the way through. You don't have to do anything.
I'm running on like 4 hours of sleep and 88 grams of food right now.
Oh boy.
So,
Okay. So 13.2 and 13.3. All right. So like I said, this would have been like the basic stuff you would have learned if you were in a CP Algebra 2 class crash course right before your state test. They usually run out of time. They as in myself, I usually run out of time too, and it's like, let me get some trig in there. This would be that section. Okay. So it's pretty straightforward, and it's the basics of how you're going to approach a lot of the things, especially with the unit circle. So standard position, like I've talked about before, that's why that 0 is on that right-hand side over there for y'all, always. That positive x-axis is always your initial side. So when we're looking at angles in general, I have my initial side, and then you also have what's called your terminal side. Okay, that's where you end. Terminal, okay, don't like to say it, but terminal illness, okay, where it ends. Where else do you hear that? I mean, it sounds bad to say, but that's where else do you hear that? So it makes sense.
Philosophy.
yeah, or just like the word terminate.
That's also something that we learned in school. So
Yeah,
you connect
also
it to
just
our
the word like
See, I don't know.
like terminate or like terminator or something.
Okay, so your initial side, your terminal side. Now you're not going to forget it. You're welcome. So
I knew you were going to say
tell
it.
me-
Like, I was just waiting.
tell me the difference between those two angles, besides their color, besides anything else. Tell me the difference between those two.
Yeah, you already knew.
Tell me the difference between those two. It's already taken you too long to figure it out. Okay? So
What?
here's the difference. There isn't a difference
What?
Trick question.
besides the color. Okay? So here's the thing.
That one's negative angle.
Back in the good old days, when you were in geometry, if you got to this point, if I asked you to draw 45 degrees, you just drew that, okay? You might have drawn that with it, okay? But it was just floating. It was just there, all right? Now, if you drew something more than that, you would just draw it extra, okay? So the main thing when you're drawing these angles in standard position, you have to tell me where you started and where you ended. Okay? And that's where that arrow comes into play. So I can say, hey, this is, 120 degrees. But then you show me that and I'm like, that's 120 degrees also. But you have to show me that I started here and I ended here. Same thing for a negative angle. I started here and I ended here. Okay, so positive angles are counterclockwise and negative angles are clockwise. Okay, so if you think about with positive angles, you start with the initial side and you go up. Negative angles, you start with the initial side and you go down. Okay, so to be careful to make sure you're showing me, hey, this is where I started, this is where I ended. So one of the main things we're going to do is actually drawing these angles. We're always going to draw them with that X and Y axis as well. And we'll go back to this slide as well and reference it in another term that we're going to learn. Okay. So what I want you to do now is I want you to draw out these 4 angles. We're going to sketch these angles. You have 100 degrees, you have negative 50 degrees, you got 200, and you have negative 200. So go ahead and sketch out where these angles would be. Do not forget your X and Y axis. Okay, so for the first one, I start with my initial side. And if I know this is 90 degrees up here, I'm just going to go a little bit more. Not asking you to get your protractor out to do it. Okay, so just kind of ballpark it. Negative 50 degrees if I start with my initial side. And if I know this is 90, I know halfway through is about 45, so then I'm just going to go a little bit past that, and I'm going to show I went backwards. (200 degrees), I know that this is 180, so I need to go about 20 more. And lastly, if I know that this is negative 180, I just need to go 20 more. And I have my negative 200 degrees. Okay. So when you're doing your negative angles, it's still that same distance. You're just going backwards that amount. Okay, so let's go ahead and look at negative 50 degrees for a second. What if I asked you to tell me another angle, if I didn't have the arrow pointing down, just another angle that would look like that? What would you tell me? If I didn't have this here, what would be another angle that would look like that? How much? 310. How'd you get that?
360 minus 50.
Okay, add 360 to it. Okay, or you could have said 360 minus 50 kind of thing as well. Okay, Okay. So that one would look like that, 310 degrees. Okay. So what that means, notice how this yellow line and this blue one, they both started at the initial side and they both ended at the same terminal side. They had different journeys to get there, okay? They both started and ended at the same spot, but they had different journeys to get there. That's called a coterminal angle, okay? So if you think about like a coworker, someone you work with, so they are coterminal angles, meaning they're both going at the initial side and they both end at the same terminal side, but they just have different journeys to get there, okay? So I could ask you the question, find cosine at negative 50 degrees, when in reality, you can just find cosine at 310 degrees, because they mean the same thing, okay? In regards to solving. They don't mean the same measurements of angle, but they both end and begin at the same spot. Okay. So this is what I was saying. I was going to reference back to the ones we drew at the beginning. So notice how I started and I stopped at the same spot for both of those. One was a positive angle, one was a negative angle. So a lot of times when y'all do coterminal angles, they're going to want literally a positive and a negative angle. Okay? So a positive and a negative angle. All right, what Dylan was saying is that he just added 360 or subtract 360. So that's how you're going to approach every single one of these problems. You're going to take your angle measure and you're going to add 360 or you're going to subtract 360. Okay? Because if I want to keep going around in a circle forever, I can. So if I have, this is one of my options, but maybe I want another positive angle. Well, that just means I went around the circle an extra time and then some. So then that extra time and then some is 360 and the angle. Okay? So that's why we're going to add 360 and subtract 360. Okay? So instead of drawing all of these out, I'm going to delete all the circles. I just want you to find a positive and a negative. So in your answers, you should have a positive number and a negative answer for your coterminal. So go ahead and find both a positive and negative coterminal angle for all four of these examples. In some cases, you might have to keep adding and subtracting 360. Yeah.
Yeah, so you want us to get a negative or a positive for all?
Negative and a positive.
Oh, for both?
Uh-huh.
What was the definition of coterminal angle again?
I'm sorry?
What was the definition of coterminal angle again?
Two angles that have the same initial and the same terminal side. So they start and stop at the same spot. And we'll add 360 and subtract 360 to find them. All right, so some of us may have said 860. You're not wrong, okay? You just want to say, I'm going to add 360, subtract 360, and be done. Go for it, okay? If you notice, if you subtracted 360, you got another positive angle. So you actually had to subtract 360 one more time, okay? Now, on your textbook, a lot of times, not every time, but a lot of times, they'll pick the smallest. Yeah, negative 220. A lot of times they'll pick the smallest of the two. Don't think that your answer is wrong by putting 860 on there, okay? If you put 860, if you kept adding 360 over and over and over again, you're not wrong. They are still technically coterminal angles, unless they tell you you have some restrictions on how far you can go, okay? So, but literally they want a positive and a negative answer, okay? So, the next one, if we add 360, we get 210 degrees. And if we subtract 360, we get negative 510. Okay? That one's pretty straightforward. Okay, what about the next one? What did y'all get for your positive angle? Yeah.
300.
Okay, and what did you get as your negative?
Negative 400.
Again, add 360, subtract 360. Okay. And what about the last one? Who's got my positive? Hey, Jenna?
315,
All right, and what was your negative?
negative 45.
Good. Okay. Because if you were to literally draw these out, if I had negative 150, I know that I'm over here somewhere. And then if I was to draw 210 degrees, conveniently, that's right there. Okay. And then if I needed to find negative 510, I would go here. This is 360 plus the 150 that's there. That's how we get the negative 510. Okay. I can have you keep going in circles for days if I wanted to. All right. So, but that's what that means. They all start and stop at the same spot. Yeah.
So there's technically infinite coterminal angles for everything.
100%. Yeah. You can keep going on forever. Because you can keep adding 360 and subtracting 360. And the reason for that being is, like I said, I could sit here and ask you the question, what is cosine at negative 510 degrees? And you would say, well, that's not on my unit circle. But I could find another angle that is on my unit circle, and then I could find that answer. I probably wouldn't go to negative 510. I'd probably go to 210 and then go from there. Which 210 degrees, yeah, like I said, you have to get creative there. But that's how you would find it. So that's what it's basically doing. It's setting us up to help us solve more things. Okay. Any other questions on coterminal? Okay. Let's take a quick break and then we'll continue on. You said logarithms review. You just turned it in recently? You turned it in last week?
Few times, like
Hold
when I
on,
was
let's see.
like on the day of testing, and then it's upstairs, so it's one of so it's
Yeah, because it shows you turned it, the only thing you turned it in was the 11th. But it's in there, so I'll write it.
strange.
Someone's probably wearing heels.
Every day, I just wanna know what they do every day.
Walking.
Any science teachers wear heels?
And strut across the room.
Yeah.
Yeah, Jinx thing.
Doing
All right, let's go ahead and finish 13. Well, we finished 13.2. Now we're going to go into 13.3. So, basics.
My favorite.
So, if you were, like I said, in an Algebra 2 CP class, and it was down to the wire, and you wanted to teach them at least one thing about trig, this is what you would have been taught. How to convert radians to degrees, okay? And degrees to radians. So on your unit circle, let's look at this for a second. So let's say I gave you 30 degrees. What is the radian measure that's also there?
5 or 6.
5 or 6. Okay. So we are going to convert radians to degrees and degrees to radians. Okay. So if I told you how we're gonna convert these. Go ahead and look at 180. What's the measurement for radians at 180? Pi. They mean the same thing, okay? So when we're converting degrees to radians and radians to degrees, we're gonna multiply by pi over 180 or 180 over pi. Why would I do that? Because pi over 180, if you have the same thing over itself, what do you get? 1. Okay? So we're not changing the value of the problem, we're just manipulating the way it looks. Okay? So let's look at 30 degrees for a second. If I multiply by pi over 180. If y'all remember back, I don't know if you've been exposed to it or not, but this is how my science teacher taught it to me. Like, let's say I wanted to change 36 inches to feet. And they would say, okay, well then you have to put that 12 inches equals 1 foot. And they would have it set up like this because then your units of measure would cancel out because you have one over the other. And then you would just multiply straight across and you would find your answer.
Oh, dimensional analysis.
I love stoichiometry.
Choose that again.
No, it's stoichiometry we talk about.
I know, we did that, but we did this exact thing in chemistry. Like,
Did you?
for like 2 weeks, yeah.
Yeah.
Not again.
So it's something along those lines, but 10 times easier. Okay. But that's what we're doing. So if you're starting with degrees and you want radians in the end, then you want degrees to be in the denominator. Okay, because you want the degree measurements to cancel. Okay. So in your calculator, do 30 divided by 180. And make sure it stays a fraction. If it changes to a decimal, just hit math frac. What do you get? 1/6. Well, notice how I didn't tell you to type pi in there. Leave pi out. Just worry about the numbers. So you got 1/6. Convenient. That's what it is. Pi over 6. Okay. So we're just converting between the two measurements. All right. So looking at 27 degrees, I'm still going to multiply by pi over 180. This one's not on our unit circle, so we visually can't see that we got it right. So technically my degrees cancel. And what you're doing when you type 27 divided by 180 is you're just reducing the fraction. That's all you're doing when you type it in. So then you should end up with 3 pi over 20. Like I said, that one's not on our unit circle, so it's not one that we can say, oh, I can look that up right there, and that's where it is. Okay, so go ahead and convert the other 3. 160, if we multiply that out, you should have ended with 8 pi over 9. 150, that one you can actually see on your unit circle. That's going to be your 5 pi over 6. And because it's negative, it just stays negative. Not anything fancy to it. Okay. And then if you look at 270 degrees, that's down there at the bottom. That's your 3 pi over 2. But if you converted it, you should just get negative 3 pi over 2. So I'm just trying to show y'all that they're the same thing when I say in reference to your unit circle. But that's what we're doing. We're converting between degrees and radians. And now we're going to go backwards, radians to degrees. So before I wanted degrees to be in the denominator so that unit of measure would cancel. Now I want pi to be in the denominator so the pi's will cancel. So if I multiply by 180 over pi, then my pi values over here cancel, and I'm basically going to do 3 times 180 divided by 5. Okay, you'll just do 3 times 180 and then divide it by 5. Okay, go ahead and convert the other 3. I'm not locking you in, I promise.
And you're locking somebody else out.
No, I think what they did when I was absent, they just unlocked the door completely so the sub could get in at 7 a.m. Because when I got here this morning, I was like, just walked right in. So it's just a safety thing to make sure y'all are safe. Okay, negative 2 pi over 3. What did that turn into? Someone tell me. Right, Jenna?
Negative 120.
Okay, what about negative 5 pi over 6? Hey, what you got?
Negative 150.
Negative 150. And pi over 6. Okay? 30. The good one. Okay, so again, just converting back and forth, if it was the bare minimum that you had to learn, that would have been it. I want to say, unless they've changed it, which you know more than I will, I want to say they even give y'all, like, converting radians to degrees, multiply by 180 over pi on the formula sheet. I'm like, out of everything you could possibly give them, the easiest thing. That's the thing, like, in some cases, they'll give y'all, like, the quadratic formula, and I'm like, out of everything, or law of sines, I'm like, out of everything, you can find something a little bit more difficult to give them, okay? So why do we need this? Not only are we going to convert back and forth, but more specifically, why would we need something like this? But there's this little formula, and I really mean it's little because it's S equals R theta.
Actually, tiny.
It's little, very little.
Yeah, it was on the first slide. But we didn't.
So if we're gonna find the arc length, which is denoted by S, that's what this side is here. We're gonna find the arc length. R is our radius. And theta, which is our angle, has to be in radians. Okay? So they can give you the question in degrees, but you have to convert it to radians or you'll get the answer wrong. Okay? So it has to be in radians. The formula. This is how you can find the arc length.
Bless you.
Thank you. How's your weekend, Miss Shannon?
It's good. Thank you for asking.
You're welcome. I'm glad.
How's yours?
Are you?
Good.
Have a nails painted? Feel
Did
pretty?
you do them yourself?
No.
Good job, Kylie. Is there any significance?
It's Una's Honest.
Huh?
Una's Honest.
A YouTube channel that ended on Friday.
It's Latin for
Man.
1 year. I think we had it for 1 year.
We were sitting at like auditions for Indoor on Friday, and they had to keep yelling at us because we were all looking at Christina's
You were
phone.
watching the stream?
Yeah, we were watching it on Christina's phone, and for some reason none of us were looking at any other person's.
I went to sleep at midnight and I set an alarm for like 2 in the morning so I could watch the last hour.
I didn't watch any.
That's dedication. The only time I've ever done that was for the royal wedding.
They deleted the channel.
Yeah, they started.
Anyone else relate to that? Because I did. I was,
Yeah, they
y'all
started.
are probably too little.
I was in New York when Harry and Meghan.
Oh, yeah?
I was like, oh my gosh, they're getting married. And so we woke up and got breakfast. I was like, what?
Ah,
Rolling is like a good month.
I never watched any.
yeah, that's the only thing I've really set my alarm for to wake up to watch was when Kate Middleton got married.
Look up like an art.
Okay, so the first example is in radians, so we're good. This makes our answer and question and everything like that super simple, okay? So if I want to solve for my arc length, I'm just going to do my radius times my theta, which is already in radians, so I'm good. But I don't know, it depends on what they're asking of you. They might have you just leave it as 2 pi, or you might have to literally type in your calculator 2 times pi. And y'all have seen the pi button on your calculator. Just go by what they're expecting. If they're like round to the nearest, then you know, okay, I need to multiply 2 times pi. But if not, you can just leave it as that, okay? So then the next one is not so simple. I can't just sit there and say, I'm gonna do 2 times 30 degrees because it's not in radians. So if you put your answer as 60, you got it wrong, okay? So I'm gonna first convert 30 degrees to radians. Now, you're going to get to a point where you're going to know that unit circle so well that you're not going to convert 30 degrees. You're going to know automatically that's pi over 6, okay? That's going to be that pre-cal world you're going to live in where those things are just going to come natural to you, okay? So if I do pi over 6, like I said, depends on what they're asking of you. If they want that or if they want you to literally divide pi by 3, to get an answer. So they could ask you for both of those. So just play to the judge, if you will. On my test, I'd take both, but I also did not make the state test, so they didn't ask my opinion.
Well, you need to sign up and follow us. Like whenever like you should make every state test we do, so that, and you should make them easy. So that we, yeah, or just this.
It's
So
like,
it's still technically speaking in the curriculum.
yeah, make them like,
All right, any questions?